To solve a compound inequality containing OR, find all the values of the variable that make at least one of the inequalities true. Problem 6. Solving an OR inequality. What is the solution of 7 plus k is greater than or equal to 6, or 8 plus k is less than 3? Graph the solution. Again, we'll consider the inequalities separately. First, 7 plus k is greater than or equal to 6 simplifies to k is greater than or equal to -1, and the inequality 8 plus k is less than 3 simplifies to k is less than -5. Here we can see these inequalities graphed. In blue, with k is less than -5, and in reddish-orange, k is greater than or equal to -1. Or, in our compound inequality, means that a solution makes either inequality true. So we'll transfer both graphs into our final graph. We'll have the k is less than -5 graph as well as the k is greater than or equal to -1 graph. Because of the word OR, any solution that makes one of the inequalities or the other one true is the solution of the set. Your turn, part A. What is the solution of the compound inequality 7w plus 3 is greater than 11, or 4w minus 1 is less than -13? Graph the solution. And part B, what is the solution of the compound inequality 16 is less than 5x plus 1, or 3x plus 9 is less than 6? Again, graph the solution. And a great concept summary to add to your notes. And inequalities, some information on the left, or inequalities on the right. First, with an and inequality, the solution of an and compound inequality contains all the values of the variable that make both inequalities true. For example, x is greater than or equal to 8 and x is less than 14. Graphed, a solid point, boundary point at 8, another at 14, and a line segment connecting the two to represent all solutions that satisfy both inequalities. The graph of an and compound inequality is the intersection of the graphs of the two inequalities. Or inequalities. The solution of an or compound inequality contains all the values of the variable that make either inequality true. For example, x is greater than or equal to 8, or x is less than 14. Graphically, we could consider the graph of x is greater than or equal to 8. That would be a solid boundary point at the point 8 and an arrow pointing to the right. And the graph of x is less than 14, that would be an open boundary point or hollow boundary point at 14 and an arrow pointing to the left. So we'd have some overlap. Putting those two graphs together and considering all values that satisfy one or the other, or both in some cases, we would get all real numbers. So the graph would be a line extending in both directions. The graph of an or compound inequality is the union of the graphs of the two inequalities.